To determine if the narrowboat can float in the canal, we need to model the canal's cross-section as a quadratic curve and check if the required depth for the narrowboat can be accommodated. Okay. Let the deepest point C be the origin. Let it be this. Here is the C. So this is our C. And since the canal is 3 meter depth, right? So the water surface is at y equal 3. So this point, and the surface of the water, that means AB, it measures 2.5 meter across. So since the parabola is symmetrical, the points A and B will be, A will be at minus 1.253 and A will be, and B, it will be 1.25 and 3. Okay, so and at Y it is 3. Okay, so the equation of a parabola opening upward with its vertex at the origin it will be in the form of x square equal 4ay. Okay, so the coordinate of C is 0, 0, right? So, and of course the parabola is open upward, so the equation will be y equal kx square. So if I am using the point B, 1.253 on the parabola, I got 3 equal k times 1.25 the whole square. So that means so let's solve for k. Solve k. So 3 equal k times 1.5625 and k equal 3 over 1.5625. That means it is 1.92. Okay, so therefore the equation for of the quadratic curve representing the canal's cross section will be y equal 1.92 x square. Okay, and now we have to determine the water level for the narrowboat. Okay, so the narrowboat, it has a width of 2.2 meter. Okay, so, and it needs to maintain a constant depth of 1 meter below the water to float. So that means the bottom of the narrowboat, it will be 1 meter below the water surface. Okay, so let the depth D, and the narrowboat, it needs a water depth of at least 1 meter under it, right? So the narrowboat is 2.2 meter wide, right? So its edges will be at x equal minus 1.1 and x will be at 1.1 related to the center of the canal. So and now we have to find the height of the canal walls at x equal plus or minus 1.1. Okay, and now we can substitute the value of x equal 1.1 in our equation, that is y equal 1.92 times 1.1 square. We got 1.92 times 1.21, that is it is 2.32 meter. Okay, that means at a width of 2.2 meter, the canal's depth is 2.32 meter from the deepest point C. Okay, so now let's check if the narrowboat can float. Okay, So here the narrowboat needs a constant depth of 1 meter below the water, right? So so the minimum depth of the canal required at the edge of the water is 1 meter plus the depth of the water itself, right? So and the canal is 3 meter depth. It's given at its deepest point, right? So the narrowboat, it needs a depth of 1 meter below the water. So, and if the water is at y equal 3, water level is at y is 3, and the narrowboat, it needs a 1 meter depth, right? So then the bottom of the boat, it will be at y equal 2. So at a width of 2.2 meter, the canal sorry, the canal's depth is at 2.32 meter from the sea, from the bottom. So that means since 2.3232 meters, it's greater than 1 meter. So of course the narrowboat will be able to float.